What is the phylogenetic tree or the evolutionary tree of life? And what can we learn by running it back and studying ancient gene sequences as you have?
I think phylogenetic trees could be one of the most romantic and beautiful notions that can come out of biology. It shows us a way to depict the connectedness of life and all living beings with one another. It itself is an ever evolving notion. Biologists like visualizations, they like these graphics, these diagrams, and tree of life is one of them.
So the tree starts at a common ancestor
It's actually the other way around. It starts
at
from
the end.
it starts from the branches. It starts from the tip of the branch actually, and then the further depending on how what you collected to build the tree. So depending on the branches, depending on what's on the tip of the branch, and I will explain what I mean, the root will be determined by what is really sitting on the tip of the branch of the tree.
So we could study the leaves of the tree by looking at what we have today and then start to reverse engineer, start to move back in time to try to understand what the rest of the tree, what the roots of the tree look like.
Exactly. So the tree itself, by just taking a few steps back and looking at the entire tree itself, can give you an idea about the connectedness, the relatedness of the organisms, or whatever, again, you use to create your tree. There are different ways. But in this case, I'm imagining entire diversity of life today is sitting on the tips of the branches of this tree. And we look at biologists, look at the tree itself. We like to think of it as the topology of the tree to understand when certain organisms or their ancestry may have merged over time. And depending on the tools you use, you might use this tree to then reconstruct the ancestors as well.
And so, what are the different ways to do the reconstruction? So you can do that at the gene level, or you could do it at the higher complex biology level, right? So, in which way have you approached this fascinating problem?
We approached it in every way we can. So it's the gene, could be protein, the product of the gene, or species, or could be even groups of species. It will depend. It totally depends on what you want to do with your tree. If you want to understand certain past events, whether an organism exchanged a certain DNA with another one along the course of evolution, you can build your tree accordingly. If you rather use the tree to reconstruct or resurrect ancient DNA, which is what we do, then in our case, for instance, we do both gene, protein, and species because we want to compare the tree that we create using these different information.
Okay, well, let me ask you the ridiculous question then. So, how realistic is Jurassic Park? Can we study the genes of ancient organisms and can we bring those ancient organisms back? So, the reason I asked that kind of ridiculous sounding question is maybe it gives us context of what we can and can't do
Yeah,
by looking back in time.
yeah. So dinosaurs or all these mammals in at least for us
Mhm.
is the exciting thing already happened by the time we hit to larger organisms or to eukaryotes.
Oh, to you, the fun stuff is before we got to the
The
mammals.
fun stuff is what people think is boring, I think. The phase that, well, at least two different times in the geologic history. One is the first life, past origin of life. How did first life look like?
Mhm.
And the second is why do we think that over certain periods of geologic time, no significant innovation happened to the degree of leaving no record behind?
So, what do we not have a record of? Which part? So you say the fun stuff to you is after the origin of life, which we'll talk about. After the origin of life, there's single cell organisms. The whole thing with the photosynthesis, the whole thing with the eukaryotes and multicell organisms, and what else is the fun stuff? The whole oxygen thing, which mixes in with the origin of life. There's a bunch of different inventions, all that have to do with this primitive kind of looking organisms that we don't have a good record of.
So I will tell you the more interesting things for us.
Sure.
One is the origin of life, or what happened right following the emergence of life. How did the first cells look like? And then pretty much anything that we think shaped the environment and was shaped by the environment in a way that it impacted the entire planet, that enabled you and I to have this conversation. We have very little understanding of the biological innovations that took place in the past of this planet. We work with a very limited set of, I don't want to even say data because they're fossil records. So let's say imprints, either that comes from the rock and the rock record itself, or what I just described, these trees that we create and whatever we can infer about the past. So we have two distinct ways that comes from geology and biology, and they each have their limitations.